Okay, so we're going to begin to understand how to add and subtract polynomials. But before we can add and subtract polynomials, we're going to spend some time with some vocab and spend some time with this word, which is a monomial. Okay? So, you've probably seen these before, right? So, monomials are single termed entities. Okay, so let me give you an example of a couple monomials that you wouldn't even think. The number 18, that's a monomial. All right, that's a monomial. It's a single entity, right? Z is a monomial. Negative 4x squared, that's a monomial, right? 2.5xy to the third, that's also a monomial. But a over 3, this is also a monomial. These are all monomials because they are single entities. You can put a box around them without doing anything other than multiplying or realizing that it's just a number by itself or dividing. So notice that we're not adding or subtracting anything with this one. Right? So these are called examples of monomials. All right. After we talk about monomials, then we begin to talk about the degree of a monomial. So as an example, let's say I gave you the degree of this, 5x. The degree is dealing with the exponents. So in this particular case, we look at the exponent on the variable, right? The exponent on the variable in this case on the x is a 1. So this has a degree that's equal to 1. The degree of that monomial will be a degree of 1. Okay? What do you think? This is a monomial, right? The number 4. What do you think its degree is? Well, not 1, because we could write this as x to the 0, huh? Because anything to the 0 power is 1. 1 times 4 would still give me the 4. So the degree of this one would have a degree of 0. Okay? So 5x would have a degree of 1. The number 4 would have a degree of 0. But what about if I gave you something like this? 5x squared y to the third. 5x squared y to the third. Now, which one do you pick? Well, you actually, this is a 5th degree. How come? How come this is a 5th degree? Yeah, you add up the exponents in total, okay? You add up the exponents in total. So here we go. A little bit more practice for you just really quickly here. 6xy. What's the degree of that? This has a degree of, this is a second. That's 2, right? Okay. Second degree monomial. How about this one? 7x. What's the degree of that one? 1. Very good. How about the number 5? What's the degree on that one? 0. That's the number 0. That's the number 0. All right there. Okay. So we're talking about the degree. What about the number 0?
The degree of the number 0.
Yeah. 0 has no degree. Yeah, isn't that crazy, right? 0 has no degree.
Couldn't it be written as 0x?
Once we have monomials down, then we can start talking about polynomials. Now, if you take any Latin roots, poly means many, right? So if we take a bunch of monomials and we start adding and subtracting them together, then we get polynomials, okay? And the first thing we learn how to do is add or subtract polynomials. So in this case, like, let me give you an example of a polynomial. Here's 3x squared plus a 5x squared. Okay, this is a polynomial. All right. We can combine like terms and add this together. Now, what does it mean to be like terms? There's two things that have to happen. Will, do you know? They have to have the same variable and they have to have the same exponent. Okay, so this is an example of two terms that are like terms. So I can add like terms together. In this particular case, if I have 3x squareds and 5x squareds, I have a grand total of 8x squareds. Okay, now that turns in, that right there, 8x squared is, as it's written, that's a monomial, and the degree is what? 2. Very good. The monomial and the degree is 2. All right, very good. What if I gave you this example here? Okay. What if I did 4x cubed y minus x cubed y? Okay, can I subtract these two monomials together? I can subtract these two monomials together. Why? Because they are the same base, right? X and y. I have an x and a y, and the x is to a power of 3, and the y is to a power of 1. So these two monomials can be subtracted. So 4x cubed y minus 1x cubed y gives me a grand total of what? 3x cubed y's. All right, so I can, and what would be, that's a monomial. What would the degree of that monomial be? It'd be 4, right? Because I add the 3 and the 1 together, that's a degree of 4. What would the coefficient be? 3, very good. The coefficient would be a 3, all right? So, okay, how does this break into polynomials then? Well, when we start adding and subtracting a bunch of monomials together, we create a polynomial, okay? So I'm kind of like, I'm putting all this in together into one box. So here would be an example of a polynomial, right? So let's say I have 3x to the 4th plus 5x squared minus 7x plus 1, okay? This is our first real example of a polynomial, and you can see that it's a collection. It's a collection of little monomials, right? So what are the monomials that I have? Well, I have this right here, 3x to the 4th, that's a monomial. I have 5x squared, that's a monomial. I have 7x, and then I have 1. So all of those together collectively make a polynomial, which means many, like nomials, right? And then we always talk about the standard form of a polynomial. So let me erase all this stuff here in the clouds and everything. Okay? The standard form. The standard form of a polynomial is written when the degrees are descending from left to right. Okay? So what do I mean by the degrees left to right? I mean this polynomial right now is written in standard form because the exponents are written in descending order from left to right. Notice I have a 4, I have a 2, I have a 1, and then I have an x to the 0. So I've got 4, 2, 1, 0. Now I'm missing a cube, but that's okay. I don't need it as long as they're written in descending order. That's called standard form. Now how do I talk about the degree of this polynomial? The degree of this polynomial, the entire polynomial, this is a 4th degree polynomial because 4th is the biggest exponent that we have. That's a 4th degree polynomial, the largest exponent that we have. Does that make sense so far? Okay, good. So if I give you the number 6, okay, that's a polynomial, right? What is the degree? What is the degree of that? The degree is 0. Very good. Okay. What would be the name that we would be using the degree? The name that we would use for this is called constant. So you can imagine, like I said, the line y equals 6. That would be a constant line, right? It's just constant. Y equals 6. Never changes. Okay, how many terms does it have? It has only one term. Very good. And then the name that we would use just from the terms point of view will be monomial. So I could be describing for you a constant monomial. That's like the number 6 or the number 8 or the number 9, right? Or the number -3. It's a constant monomial. What if I give you this one? Let's do 5x plus 9, okay? What will be the degree of this polynomial here? The degree would be 1, very good. How many? What would be the name that we would give to a degree? In this particular case, if the degree is 1, we call that linear, right? Think about of a line. The slope is like mx plus b form. We'll call it linear. How many terms does this thing have? This thing has 2 terms. It has 5x and it has a 9. So if it has a two-termed polynomial, we call that a binomial. What makes sense because like 2 for bi mean like a bicycle, right? There's 2 wheels. Okay. What if I give you this one? If I give you 4x squared plus 7x plus 3. Okay. Well, what would be the degree of this? The degree would be 2. The name that we give to a second degree polynomial is a quadratic. So when you hear the word quadratic, you know you have a polynomial with the highest degree of 2. That's good to know, okay? The number of terms that I have in this case is what? I have 3 terms, okay? If I have 3 terms, then I have a trinomial. That makes sense because tri stands for 3, like triangle or tricycle, so I know I have 3 terms. So if I'm talking about a quadratic trinomial, you have a visualization of what that should look like. 5x squared plus 2x minus 8. That's a quadratic trinomial. So there's all these words that we have that we can use to describe polynomials, okay? All right, let's keep going. I think I've got 2 more for you to do, okay? Have you ever seen it organized this way before? No, okay. Hopefully this is helping you, okay? Let's do this. Let's do 2x cubed, okay? What will be the degree of this?
3.
The degree will be 3. So if I have a third degree, we call that a cubic.
How many of these are there? Is there like one without one?
No. I'll tell you what we do after this, okay? How many terms does this thing have? 1. So what's it called? Very good. So if you hear a teacher say a cubic monomial, you should know what that is different, or how that's different from a constant monomial, right? Okay, very good. Let's.
Say quadratic monomial?
Yeah, you could have a quadratic monomial. That'd be like 5x squared, right? 5x squared is a quadratic monomial. So all these words can now describe what we have. Let me shrink this down so we can still see our list, okay? Last one, let's do this. Let's do 8x to the 4th. 8x to the 4th. Let's do minus 2x cubed. Let's do plus 3x. Okay, good. What would be the degree of this? 4. Notice that I have a single variable polynomial, right? I have a single variable polynomial. So the degree of this is 4. Very good. What will be the name for the degree? Well, from here on out, from 4 on up, we just call it a whatever degree polynomial. So this would just be a 4th degree polynomial. So if I gave you like if I gave you like 8x to the 40th, that would be a 40th degree polynomial. So there's no real fancy names that we use past 3. So you have to know the names for the degrees of 0, 1, 2, and 3. That's it. Okay? Number of terms should still be what, everybody? 3. So what do we call that? A trinomial. Very good. Okay? So if I'm talking about a 5th degree trinomial, right? Here's a 5th degree trinomial. 5x squared plus 8x to the 5th plus 1. That's a 5th degree trinomial, but it's not written in what? Standard form. Why not? How could I put this in standard form?
8x to the 5th plus 0x to the 4th.
Yeah, you don't have to write the missing ones. Just put the ones that you see. It's a good idea. Yeah, you don't have to put the placeholders in for this particular lesson. Yep. Cool. So here's a homework problem, right? They're gonna say, first write it in standard form. So everybody tell me what I should write down in standard form. 5x cubed. Go ahead, shout it out.
Plus 11x.
Yeah, because look, I have 7x and then I have 4x, right? So yep, I have 11x. Very good.
Minus 1.
Minus 1. Good. So now that it's in standard form, okay, tell me the degree.
Cube.
So this is a 3rd degree, right? So what do we call those?
Cubic.
3rd degrees are called cubic. And how many terms does it have?
Trinomial.
Very good. So the answer that you would write down would be this: cubic trinomial. Does that answer your question, Brandon?
Yeah, I like remember what I was trying to ask.
Here's a silly one, right? So this would be a 14th degree 1, 2, 3, 4, 5. So this is a 5-term 14th degree polynomial. That's all you'd say. Okay. This is as easy as it is supposed to be, okay? We're going to add and subtract 2 polynomials. So notice that I am adding this polynomial with this polynomial over here, okay? So can we describe the polynomial on the left?
It's a 3rd degree.
So 3rd degrees have a name. Those are cubic. It's a 4-term cubic, basically, right? 4-term cubic. 4-term cubic. How about the one on the right? The cubic binomial. Very good. So I have a cubic binomial. All right, great. So here's how you do this, right? All you got to do is you add the like terms up. It's really that simple. So look, I have x cubes here and I have x cubes here. I have x squareds here. That's it. I have an x here and I have x's here. And then I have an 11. So look, all those different colors. See it? All you got to do is put the right color with the right color. Okay? It's really that simple. So if I have 5x cubes and 2x cubes, how many do I really have? Yeah, I mean, it's that easy, right? So I have from here, I have a collection of 7x cubes. And I like to cross them off because I like to keep track of them. Now, I only have one blue colored, so that's just negative 3x squared. And you'll notice that as I'm doing this, I am writing it in which form? Standard form. I encourage you guys to do the same thing because you don't have to rewrite it again at the end. So start with the biggest ones and work down, right? Okay, if I have 14 x's over here and I take 3 of them away over there, how many do I really have? I have a positive 11x, right? And then I have this minus, was that an 11? I can't read it anymore. So there we go. There's our answer. Okay, now let me give you another example. We're going to be subtracting now. And this is how it could be presented to you in a problem in the book or for homework on a test or a quiz. The important thing to remember here is this. This is how my brain sees this. I have a bunch of stuff, which I'm just going to call green. And then I have a bunch of stuff, which I'm going to call yellow. I have green and I have yellow, okay? Of the two colors that I've just highlighted, green or yellow, what's the negative one? The yellow. Why am I doing this? Because people forget that the one that's negative is the stuff that comes after the subtraction sign. Why is this important? Because you need to remember to distribute that minus sign to every single term in the yellow. If you don't, most people just subtract off a 7x cubed and they forget about the other two terms and they mess up the whole problem. So what I would suggest you do is you write this out in two ways. The book will tell you to do things vertically. Okay, so if I was going to do this vertically, here's what it would look like vertically. I'd have x cubed, I'd have minus 3x squared, and I have a positive 5x on the top. Then I would subtract from that, 7x cubed plus 5x squared minus 12. Well, hold on a second. Okay, then go like this. Okay, and then work vertically down. So x cubed minus 7x cubed, how much is that worth? Negative 6x cubed, okay? 3x squared minus 5x squared. Negative 8x squared, okay? 5x minus a minus. So that'd be a plus 5x. Oh yeah, check that out. There was 5x and there was no 12, right? So I actually should have written that to the right a little bit more. And then I finally have a what? A positive 12. You see that? I don't like this way. This is not how I like to do things. What I would just do is write this whole thing over as one problem like this. X cubed minus 3x squared plus 5x minus 7x cubed minus 5x squared plus 12. And I would write it as one giant long polynomial and then work from there by going, okay, which ones are my like terms, right? So and I would circle my like terms and then I would go from there. That's how I do it. I think it's far less confusing than the vertical way that the book will present, but they're going to give you two different ways of doing it, all right? I say go with whatever way makes you happy. All right, you try. You and the person sitting next to you, whichever way makes you more happy, go ahead and see if you can get the right answer for this one. Okay, Luis, tell us what you got, buddy. Negative 8x to the power of 5.
Plus 6x to the power of 3.
Plus 6x cubed.
Oh yeah, plus 12x to the second power.
Plus 12x squared.
Minus 9x.
Minus 9x. Plus what?
17.
Plus 17. Who agrees with Luis? Hands up. Let the record show that everybody in the classroom is having their hands up, except for Jay.